Good morning, everyone, and welcome back to a new episode of Generative Minds. Today, we are focusing on summarizing how generative AI can be used in engineering and product management. This was the second most popular use case in the poll that we have conducted about roughly a month ago, where you voted for your favorites. So, Peter, let's quickly go over the main steps of product development process and provide some examples of how generative AI can assist in each step. And regarding myself, I'll play the devil's advocate and highlight what to watch out for.
Yeah, I'm looking forward to discuss this. This was the most popular use case in my list of basically use case environments for generative AI in the industry. So going into the details, obviously engineering product management is very broad. Now that's a broad field. There are different engineering disciplines like civil engineering, software engineering, industrial engineering, and also product management. They relate, but of course they have also their dedicated fields. But I think this overview does a pretty good job. I mean, both sides, engineering and product management, they need to come up with new ideas, new concepts, develop products. So they have this in common. And what you see here in this process, as one of the examples, how you can frame it, is that it all starts with idea generation. And with idea generation, I think that's for generative AI, one of the core disciplines, one of the best things that can happen. Try it out. I mean, for example, in a promptathon, which is a workshop, we can have this as a challenge, create new products and think about it. And it's really amazing when you really work with the AIs with the prompt chain, for example, with different people also giving inputs. You can not only generate ideas, you can also assess them, get some feedbacks. You can also have two AIs talking to each other, discussing concepts. Very interesting to see that, how they argue about it. And so I think up to idea screening about the importance and value, the potential profit that you can make, generative AI can be a great support.
All right, so let's talk about concept development, for example.
Sure, and I also have some examples here. And if it opens up, you see, basically that example is nicely done by McKinsey. If from the ideation phase you have defined that a new pedal for a bike could have some market niche, is something different. If you do it, for example, here with titanium, some other material, you can prompt then the artificial intelligence for new designs. And then if you have already first designs and they kind of look different to what at least I know from pedals, then you can already work with them, create variations in the prompt progression, as they call it here, making it lighter, for example, using less material, making it more profitable in the end if you use less material for the same price. And at the end, then refine the final product as you would like to have it in this testing phase. So people can imagine, okay, how does it look like? Would I buy it? How much would it cost? All of these components would be possible if you have generated it up until here for this concept.
Perfect. What to watch out for then? So 3 main points I would say on this topic. First of all, when you ask these algorithms to propose a new product design, they might create something that looks aesthetically new and nice, but they don't take into account the technical characteristics, so potentially leading to inferior performance of the product, right? Secondly, while we can then prioritize functional performance, this could result in components that don't fit together or they're not physically possible. And that's something else that happened many, many times while trying out these models. Third, it would be necessary then to have some design constraints to ensure that the outputs are both innovative but also high performing and physically feasible. A suggestion, a tip on how to achieve these could be, for example, developing effective prompts that consider all products' characteristics and mention both the functional but also the physical limitations of the intended creation. Do you have any specific example of a product that can do that?
Of course. So, and I think this is just one of them. But if you then, as you said, you have several issues with these generative AIs. But if you then use professional engineering tools like this one, it's an X by Siemens in this case, but other providers have that as well. You see here what the designer originally came up with. I think you would know that design, right? It's kind of this clevis which connects things together. You have this bolt inside, and it needs to kind of have a certain force that pulls it and withstand that force. So now in this case, all of these design requirements have been defined, and what comes up is just a completely different design. And I think just to have this comparison between this, what we all know, and it's big and sturdy and uses a lot of material, and within these design tools, you can then define completely different looking designs which fulfill the design engineering requirements. So I think this, from my point of view, was a nice example to showcase that.
Definitely nice example, but I would like to remind everyone that a bit of post-production editing is always necessary.
Sometimes, I'm sure, yeah. And also he says clearly that, I mean, the idea is there, but he will now do all the calculations to assure that it's really working, because that's definitely necessary. And so it's really this Copilot. And a last thing I would like to also show, talking about Copilot, there are different ones, of course. The ones from Microsoft, we discussed them already. But for example, also from Siemens, the industrial Copilot. This is also a next step. After you have designed the product, you can then talk about, well, how do I manufacturing? How do I produce the product? So the engineering of production. And here, I think this is a very nice example. In the industrial Copilot for engineering, presented by Rainer Brehm.
Speed up generation of complex PLC code, generate the HMI, and ask any kind of engineering-related question. The Copilot does this all. This means less repetitive work, more productivity, and shorter development times. So
I really like that, because programming PLCs has been a big bottleneck in the industry. It's a difficult language. It's different than in the IT space, and people are less and less inclined to do that. But you need to do that if you have a new product that you want to design. You need to also accordingly program the PLCs. So this is now supported, so you're much quicker. And not only that it does program the PLCs, it also looks at, for example, the HMI, the human-machine interface, the panel, basically, just by asking it to create a button, it creates the button. So it's this easy, intuitive interaction. There, I think generative AI is great. It can facilitate and speed up many processes. And therefore, I think we're going to see much more of that.
I do believe this is very helpful, because nobody wants to modify or change the software of the PLC. And also being able to design a nice HMI is definitely a step forward. All right, then I think that for today, that's all. That was a very nice use case that we have discussed as well. And see you next time.
Bye-bye.